All right, welcome everyone, and thank you for joining us today for Power to Perform Real-World Benefits of Going Electric. I'm Marissa Kiesler, Head of Marketing, Communications, and Brand Development here at Proterra. And today we're going to have a conversation that I hope gives you some genuinely useful strategic input as you think about electrification projects for your specific application. Today, our conversation is about performance, operational advantages, cost of ownership, and worker safety, showcasing the holistic picture of why these applications make sense to electrify, and importantly, how to do it well. Joining me today is Bradley Garrett, who is basically my go-to when I have tough customer application questions. Bradley brings deep experience in helping OEMs to select the right battery for the most demanding applications. Bradley, I will let you go ahead and introduce yourself.
Yeah, thanks, Marissa. I'm excited to be here. And I've spent my career really at the intersection of battery technology and heavy-duty applications. So first, initially working as an engineer and launching new heavy-duty EV platforms, and now working directly with the OEM engineering teams on the battery selection process and integration from the sales side. So the applications we're covering today, they span a pretty wide range of operating environments, as you can imagine. And the more time you spend with each one, the more you realize the electrification case is specific to that application. It's not a one-size-fits-all argument, right? So I want to highlight that the data we'll bring up today comes from actual deployed fleets, from real operators and independent research as well. So we're already at the point in electrification where there's significant operational history across all 5 of these applications. So that actually gives us some real data to analyze. So these aren't just pilots or one-off projects, which makes this conversation more interesting than it would have been a few years ago.
Yeah.
And, honestly, I'm genuinely very excited to talk about this. So I appreciate you letting me come.
Yeah, super excited to have you here. And that operational depth that you've talked about is exactly the lens that we want to bring to each application today. We are going to move through 5 different application segments today: mining, construction equipment, port and material handling, terminal tractors, and fire and emergency. And for each one, Bradley is going to walk us through the case for why electrification makes sense and how to choose the right battery pack for that application. We'll be moving at a pretty good pace, so if you have a topic that resonates or you have questions about your application, we're going to have resources and a Q&A session at the end. The first application we're going to start with is mining. This application is actually probably my favorite that we're going to talk about because it is incredibly unique. It has a variety of uses, and there are a lot of almost hidden benefits to going electric in this application. So Bradley, when we talk about mining, specifically underground mining, it's not actually the vehicle itself that is the biggest benefit in going to electric, is it?
No, that's exactly right, Marissa. And it's one of those things that when you understand the real driver, it changes the business case a little. So one of the biggest cost drivers in underground mining specifically is ventilation. So not the equipment itself, but the ventilation system.
Okay.
Which can account for anywhere from 25 to 50% of a mine's total energy electrical consumption.
Wow.
Right? So although the concept of ventilation in underground mines may seem relatively simple, it's actually a pretty elaborate operation. So you need to get the right quantity and quality of air to where it's needed, when it's needed, in an expanding mine, right? So the primary job of your ventilation system underground is diluting that diesel exhaust and heat from the engines, right, that are running. So every diesel machine you operate underground requires a massive airflow volume to keep the worker exposure to diesel particulate matter, or DPM, within the regulatory limits, right? So by removing those diesel engines from the equation, you no longer have to focus on the DPM limits and excessive heat generated from those engines. And so you can actually recalculate your required air quantities to meet the minimum velocities to manage things like blasting requirements and gases from actual work. That being said, electric batteries, the charging, the electric motors, those all still produce heat, but it's definitely less than a diesel engine.
Yeah.
So unless you're designing a ventilation system or you're possibly a fluid mechanics professor, you probably aren't aware that fan power scales with the cube of airflow volume. So if you can reduce your required airflow by 20%, you don't save 20% on fan energy, you actually save closer to 50%.
Oh, wow. Okay.
Yeah. So removing those diesel engines from underground, you can reduce your OpEx, ventilation costs by 35 to 50%.
Wow. So the ROI case isn't just about the machine at this point, right? It's about what you stop spending on and the infrastructure around that machine. That's a really different way of framing it rather than a one-for-one equipment swap. but operations still matter, and this equipment has a really hard, heavy-duty, challenging job to do. So what does actual equipment performance look like?
Yes, great question. So underground miners who've actually run BEV gear will tell you the machines can absolutely keep up on the face and on the ramp, right? So electric motors, they give you full torque from 0 RPMs. So things like tramming, ramp starts, and mucking into the pile, they feel at least as strong as diesel and often smoother and easier to control. So the limiting factor isn't can it pull, it's how much energy you put into the battery and how smart your charging strategy is. And where BEVs really change the game is in the environment you're working in. So there's no exhaust like we talked about, far less heat, much lower noise. So the operators, they stay sharper and they can sustain high productivity, right, without fighting fumes or heat stress. That also feeds back into performance. You can keep more gear working deeper, longer, without hitting those ventilation and heat limits that would cap a diesel fleet, even if the iron itself, had more. So the one area where diesel still has an edge is runtime simplicity, right? On those super long continuous hauls, right? You can fill it, you can run a full shift, and then you can refuel fuel in minutes. Where BEVs, on the other hand, you need a designed energy plan. You need to right-size your packs. You need to charge in natural pauses or have battery swaps where the cycles are brutal. And mines that really do that well, they're seeing electric fleets match or beat diesel on tons per shift with far better conditions underground.
Yeah, that's great.
Yeah, mines that still think BEVs can't keep up are honestly experiencing an energy management problem and not a torque or a capability problem.
Yeah, okay. So Bradley, if I were an equipment manufacturer and I was looking to electrify either a new project or maybe I already have electric equipment, but I'm looking to move to a next generation, where would I even start?
Yeah, so the main inputs to select a battery are going to be your duty cycle, obviously thermal management, charging, and serviceability. So the first, right, is energy demand per cycle. The underground loaders and haul trucks, they operate on these defined routes. So they're going from the face to the ore pass or to the surface, and you need to characterize that route with things like your distance, grade profile, payload weight, cycle frequency, shift structure. All of those give you the energy required per cycle, and then you can calculate cycles per shift, which will define your minimum pack size.
Okay.
So like I mentioned, thermal management is also a design consideration that shouldn't be overlooked because mining ambient temperatures can be elevated, and the packs need to maintain its operating temperature range across a full shift. So not only are you trying to overcome the cell temperature rising from discharging the battery, but you have the ambient environment to overcome as well. So the next thing is charging architecture. It's another key decision point. And depending on your mine's infrastructure, right, and access, honestly, to reliable power, that's going to dictate your charging strategy and your pack size. So underground operations can use dedicated underground charging bays. And for high utilization applications or mines with unreliable grid access, battery swapping systems we've seen, allow a fresh pack to be exchanged rather than having to wait for a full charge cycle. And lastly, battery serviceability and reliability are honestly a non-negotiable underground. As you can imagine. The battery system needs to be reliable and designed with, easy access to serviceable components, because really every minute of downtime is money out of the operator's pocket.
Yeah, I mean, that's totally fair. So ease of serviceability, thermal management, defining your minimum energy, these are the kinds of application-specific decisions that really require a real engineering partnership between an OEM and a battery supplier. It's not something that you can just look at a spec sheet and make a decision on, right?
Exactly.
Okay.
Exactly. It's a process.
So let's go ahead and move into our next application, which is construction. This is adjacent to mining, right? But this is also an extremely broad topic. So if anyone has a specific application or a specific equipment question they're working on, we would love to dive in deeper with you, but we're going to try to keep it really high level for today. This could be anything from surface work to urban demolition, road construction, earth moving, all of these different types of applications. So Bradley, how do you frame the application case for construction OEMs who are serving across all of these different contexts?
Yeah, so it's tough, and you're right. It's a very broad application space, and that's kind of, part of what makes the electric value proposition interesting, because there's different benefits that present themselves in different contexts.
Yeah.
So let me start, with what operators really care about, and that is, does it do the job? Yeah, right.
Good question.
Field experience across multiple machine types, it consistently shows that electric excavators and wheel loaders, they're matching diesel equivalents on lift capacity, breakout force, and honestly productivity in general. Operators, right, they're frequently reporting that the electric machines, they feel more responsive, And there's a straightforward engineering reason for that responsiveness. The electric motors, they deliver full torque instantaneously. So there's no delay like you see with a diesel engine that needs to reach higher RPM before it can deliver full torque.
Okay.
Right? So when the operator moves the joystick, the machine responds immediately.
Nice.
No lag. So the other major question we get is, will it last for a full day or shift? And I would say it obviously depends on each specific piece of equipment and what each operator duty cycle is. So some operators, they're going to drive a dump truck for 12 hours a day and 90% of that is fully loaded. So in that case, the truck will need to have enough energy to handle that abuse. So beyond, will it do the job? We can see some direct benefits over diesel equipment. And one of those big ones is noise. Electric excavators, they typically achieve a 10 to 15 decibel reduction compared to diesel machines in the same class. Because the decibel scale is logarithmic, that reduction is received as actually roughly half as loud.
Wow.
Half as loud, yeah. Significant reduction.
So the noise reduction number is significant, right, as you just said, and I imagine it has a direct commercial implication for urban contractors. Can you possibly talk about that?
Absolutely. And urban construction is where that noise advantage really shines, like you said. Most urban jurisdictions, they restrict construction to specific daytime hours, right? That's to limit the disturbance to residential areas nearby. So in those specific areas, electric equipment, they could operate outside the standard windows. And, for a contractor on a time-sensitive project, securing the permits for off-hour work could actually speed up the timeline quite a bit. I want to highlight two more benefits of electric equipment in this category. First being wear and tear on the critical components, and also the operational cost savings. So for most off-highway equipment and vehicles, wear actually isn't measured by miles or kilometers like you would in a car, but by hours.
Okay.
Right. So on diesel equipment, the hour meter is going to climb anytime the engine's running. So that could be idling, at a job site. It could be warming up. And these hours are still driving engine wear, which, as we know, triggers service intervals and really eats into the machine's overall life.
Yeah.
So where the electric equipment, on the other hand, there's no engine idling away and no after treatment to clog during those long waiting times. So most of the wear driving hours are accumulated when the machine's actually doing work, not just sitting there, powered on.
Okay.
So in applications where meaningful idle time, between cycles, an electric machine can deliver the same amount of productive work while putting far fewer wear driving hours on the powertrain. So that could stretch the service intervals, support a higher residual value potentially, and lower the life cycle maintenance costs. And on maintenance, maintenance is one aspect of the operational cost saving, but energy is another one. And we're seeing independent studies reporting reductions of energy costs by 60 to 75% per hour versus diesel.
Wow. Okay, so extended working hours in urban environments, slower wear accumulation on the clock, lower energy and maintenance costs. Those are variables that can really change a contractor's total cost of ownership calculation pretty significantly, right? So how does a construction OEM approach battery selection when their machine might end up in a dense urban demo site, maybe a remote road project, or a surface mining bench across its entire working life?
Yeah, so construction is one of the more complex pack selection problems precisely because of that variability, right? Typically, battery selection is going to vary from equipment to equipment, so it's important to partner with someone who can offer a pack that's modular, so it can be tailored to each of those applications, right, if necessary. So I won't go into too much detail here because it varies so much, but I'd say first you need to identify your specific application and duty cycle, and really trying to right-size your pack for that duty cycle is key. Because these vehicles will be operating in extreme off-highway environments, vibration is another aspect to consider.
Okay.
Having a robust pack and, a rugged pack, honestly, is that's been tested at a high enough standard is going to be key for these OEMs. And depending on cell chemistry and pack design, battery manufacturers might actually adjust the warranty based on the vibration profile. So without a proven pack, you run the risk of your system failing in operation, which none of us want, and could lead to significant downtime for the customer and possibly costly replacements if you aren't covered with a strong warranty by the manufacturer. Voltage architecture is a meaningful OEM decision point as well. So higher voltage systems, kind of your 600 volts and above, those are going to support faster charging and reduce, your current requirements for a given power level. Whereas for smaller equipment that might have, longer to charge, you wouldn't necessarily need a higher voltage pack. So finding a battery partner that offers optionality and flexibility around your voltage as well is beneficial. Weight in many applications, like a dump truck and a cement mixer, is a factor to consider.
Okay.
And, a vehicle's GVW rating is going to be limited, and adding thousands of pounds of heavy batteries is ultimately going to limit the vehicle's capacity to haul.
Okay.
Right. So this is where energy density comes into play, and getting as much energy on board with the least amount of weight as possible is key.
Okay. So early engagement on right-sizing the pack. You have to look at vibration profiles, voltage architecture. Again, these are kind of design decisions that determine whether the machine performs well across its whole working life, right?
Sure.
And they're decisions that are much easier to get right at the concept stage rather than trying to do it after the fact or correct them later. So with that, we're going to go ahead and shift into one of the applications that I think is maybe more data rich than some of the others we've been covering, and that is port and material handling. So Bradley, ports and material handling equipment have some of the most intensive duty cycles in all of heavy industry, right?
For sure.
These machines are running around the clock every day, often in multiple shifts. So walk us through why that duty cycle actually makes electrification a better or stronger case than a harder one.
Yeah, so port and material handling equipment is what I'd call a tailor-made, right, application for electrification. And that operating intensity you mentioned is one of the biggest reasons. So every efficiency advantage compounds when you're running a machine for 16, 18, 20 hours a day.
Yeah.
Right? So there's a lot I could talk about here, but I want to hit on two aspects that make the case even stronger, and that is energy and maintenance. So on the energy side, right, we can start with the fundamental efficiency difference, right? Electric motors, they convert roughly 85 to 90% of their input energy into useful work. Diesel powertrains, right, accounting for the engine, transmission, hydraulic system losses, they only typically convert 30 to 40%.
Wow. Okay.
So that's right. 2 to 3 times efficiency gap is present every operating hour of every day. So at high utilization ports, all right, that translates to substantial fuel cost savings over the life of the fleet.
Yeah.
And port equipment has a unique benefit actually from regenerative energy recovery.
Okay.
So container handlers and reach stackers, right, they're repeatedly lifting heavy loads and lowering them. And that lowering movement is an opportunity to actually recover energy back into the battery. So depending on the specific vehicle and cycle profile, the regenerative recovery can offset anywhere from 10 to 20% of the total energy consumption, which is pretty awesome.
Yeah.
Whereas in a diesel machine, right, that's lost potential energy and it actually gets dissipated as just heat in a braking system. So the second point is maintenance, and removing diesel engine service, the transmission maintenance, exhaust after treatment system, and obviously a handful of fluids from the service schedule, it's going to create a substantial reduction in planned maintenance and honestly potential unplanned downtime.
Okay.
So we've looked at a few independent analyses of these electric versus Tier 4 diesel cargo handling equipment, and they consistently show that, maintenance costs can be reduced by anywhere from 50 to 75%.
Wow.
And for a fleet operating, right, and operating with a large, amount of vehicles, that reduction in maintenance is both operationally and also as you can imagine, financially significant.
Yep.
So when we look at real world deployments, port terminal operators are finding that electric equipment is doing exactly what the spec sheet promised, right?
Good.
Which is good. And the energy and maintenance savings are actually showing up,
Okay.
which is even better. So one of these deployments is at use in terminals, where container handlers and forklifts are meeting, the duty cycle requirements, but they're also delivering fuel and maintenance savings, which is awesome to see. And so kind of to sum it up, the pattern is consistent. Once the operators, they make the switch, they run the numbers, really they're coming to see that the equipment works and the uptime's there, and that those benefits that everyone talks about, they're actually real.
Yeah. So our technology is powering the workhorses of global commerce, port and industrial equipment. We partnered with Taylor Machine Works, who is a leading manufacturer of heavy-duty material handling equipment, to electrify their equipment. So think container handlers, forklifts, and reach stackers operating in, again, some of the most demanding environments. We equipped their ZLC and ZEC series electric container handlers and their ZH series of electric forklifts with our Onyx battery platform technology. So the data ends up speaking for itself. Our batteries delivered the same operational capabilities as their diesel equipment with no compromises. This means that they could get 2 full shifts of runtime from each machine with no need for opportunity charging to get through the day. But beyond performance, our batteries also prove their reliability, demonstrating exceptional durability in a really harsh salt air environment and completing over 200,000 lifts. this isn't just about saving a company money or reducing a few tons of emissions. Proterra is actively revolutionizing the logistics and supply chain industry, building a sustainable future for an entire global economy.
That's huge.
So Bradley, let's talk about the workforce piece, because in this industry, operator experience and safety are really significant factors for port operators and their labor relationships.
Yeah, the workforce impact is real, and it's often, underappreciated in this initial technical evaluation of a battery. So diesel cargo handling equipment, it generates significant noise and vibration at the operator's position.
Yep.
So sustained exposure at those levels, as you can imagine, triggers mandatory hearing conservation requirements and PPE compliance management. And in many cases, the electric equipment operates below decimal thresholds that require that mandatory protection, right? So that's a direct reduction in occupational noise burden and a genuine improvement in the long-term health of the workforce.
Which we love.
Yeah. And the NACFE documented a driver specifically in the Run on Less electric research program that they did, who had experienced progressive hearing loss from years of diesel equipment noise. So on the electric equipment that he tried out, he could hear the dispatch radio clearly for the first time in years, which is surprising, and stopped missing assignments as a result. So that might seem small, but it has real impact on worker retention and productivity.
That's amazing.
Yeah. And so one other aspect to consider is vibration. That's another ergonomic factor. Diesel powertrains, they're going to transmit engine vibration through the cab controls for the whole shift.
Yep.
Right. So electric systems eliminate that baseline vibration. So operators are consistently reporting less fatigue on the electric equipment over a long shift. And for operators running around the clock rotations, that fatigue reduction translates to fewer handling errors and incidents.
Yeah, I think that's really important. And maybe I'll add something here from my own experience. While I haven't had the opportunity to operate electric material handling equipment specifically, and I'm not sure that anybody's going to hand me the keys to a reach stacker anytime soon, unfortunately. But I have spent a lot of time in electric transit buses, school buses, and even a Class 8 truck as well. And the absence of engine noise and vibration really changes the entire working environment in a way that's genuinely really hard to communicate unless you've experienced it for yourself. It's one of those things where operators who are skeptical going in often become your absolute biggest advocates.
It always happens that way.
So now I want to flag something specifically relevant for this application. Port equipment is one of the areas where federal and state incentive programs have been active and in many cases still remain in play. So Bradley, can you talk to some of those programs?
Of course. And you're spot on, Marissa. And this is worth tracking closely for both OEMs and the terminal operators themselves. The EPA's Clean Ports program and regional air quality programs have historically provided significant funding for zero-emission cargo handling equipment. And so program availability, structure, requirements, they always change over time. So it's important that you check the status with your regional air quality management district, or you go directly to the EPA.
Yep.
But for equipment deployed in federal funded applications, domestic content requirements and manufacturing footprint for the battery supply chain are also increasingly important. So as part of any federal funded opportunity, there's a compliance dimension to that.
Yep.
So this standard is often BABA, or Build America, Buy America, which is a requirement for the EPA Clean Ports program that I just mentioned.
Yep.
So other segments, obviously, they have their own unique compliance requirements for federal funded programs, such as the FTA, they have Buy America program for transit. So Proterra is BABA compliant for the EPA Clean Ports program today due to our U.S. assembly footprint and how we manufacture our system subcomponents like module, enclosures, ancillary bays. But beyond incentive access, right, it's a supply chain resilience benefit as well.
Yeah, for sure.
So, right, having a domestically anchored battery supply chain is less exposed to risk of disruption that have been honestly increasingly common in recent years. So Proterra's manufacturing in Greer, South Carolina, where we're actually at today, provides our customers with access to BABA and Buy America compliance. Really, it's offering OEMs a clear domestic content compliance pathway. Mm-hmm. And that's a specification differentiator that, really matters in the public sector and Port Authority procurement, where we're seeing that these standards are mandatory and not just a nice to have.
Yeah, and that domestic manufacturing capability is something that we're genuinely really proud of at Proterra. And like Bradley said, it's increasingly a real differentiator in the procurement environment. So let's talk through, how do you approach pack selection for material handling and port equipment?
Yeah, so when you're selecting a battery for port equipment, the starting point is always going to be duty cycle and energy demand. I think that's pretty common across most of these applications, but you really need to understand how the machine actually works in your customer's ports. right? So energy per operating hour for all, lift, travel, and idle.
Yep.
So how many hours per shift it really runs and what, a worst case looks like when you're doing heavy lifts, right? With high stacking heights, lots of travel. From there, you can calculate energy per shift with some reasonable precision and then design to that.
Yep.
So the second pillar is researching and developing, right, a charging strategy around your vehicles. So some operations are going to lean on, your overnight depot charging with larger packs and lower charge rates. But others, they'll want a mid-size pack plus some opportunity charging throughout the day in breaks or shift changes. So a few others, they might consider things like battery swaps as well. So your pack size, your C-rate capability, and thermal design, they have to match what the port can realistically support in charger power, grid capacity, and dwell time. So in practice, you're really co-designing the pack and, your vehicle around the charging concept, not really treating it as an afterthought.
Yeah.
So finally, you have to solve pack integration and architecture. So container handlers, they have a pretty tight packaging envelope and strict axle load constraints. So getting a volumetric, energy-dense, modular pack with a lot of mounting options is going to really matter. So a modular battery architecture with common modules that can be built up into different pack sizes and voltages, it's going to let you support, right, multiple handler variants, whether that's an empty handler, a laden, a reach stacker, right? But you can do all of that with the same building blocks. And on top of that, you need the right system voltage. Typically, it's in the range of 600 to 800 volts, enough peak power for repeated high current lift cycles. You also need to be able to support the robust cooling system for hot port environments and have, right, a lifetime profile that's going to meet expectations.
Yeah, all really important information. So Bradley, we've talked about material handling and port equipment. I kind of want to switch gears and go to terminal tractors, which are used at ports, but they also have other applications. So I kind of wanted to break those out. This segment with terminal tractors may actually be one of our strongest single use cases for electrification, I think, in heavy duty transport. Maybe Bradley, you can back me up on that and explain why.
Yeah, I think you're exactly right. And when you look at terminal tractors and their drive cycles, they're almost perfectly suited for electrification. So many of the challenges that long-haul tractors face with electric powertrains, they just don't exist in this application. So terminal tractors, they operate at low speeds, high torque. They have a constant stop-and-go duty cycle and have relatively low daily mileage and a lot of idle time.
Yep.
So durability is also critical in this application. And those are all areas where electric powertrains really shine, which is why we're seeing electrification make a lot of sense in this segment. So we could probably spend an entire webinar talking about terminal tractors, but I want to focus on one of the areas where fleets see the most headaches with diesel engines in terminal tractors. So as I mentioned earlier, the duty cycle, it's very different from your typical highway truck. Terminal tractors, they're running on, at low speeds, doing short moves. They're starting and stopping constantly and spending a lot of time idling. And in many cases, idling alone can make up 30 to 50% of their operating hours.
It's a lot.
It is. So without getting, too far into the technical details, that kind of duty cycle means the engine is often operating at, low load and cooler temperatures. So combustion reactions inside the engine aren't as complete. And so that actually leads to higher soot production.
It's not good.
Not good. So highway tractors are the opposite, right? They spend long periods under load at high temperatures. So they tend to run hotter and cleaner and don't build up soot nearly as quickly. So diesel, the diesel engine relies on an aftertreatment system to meet emission standards and deal with this soot. And a big part of that is the, diesel particulate filter, or DPF.
Okay.
So that DPF, it captures the soot from the exhaust and it has to periodically burn it off. And
Yikes.
that happens through what they call a regeneration event. So that requires higher exhaust temperatures. And in long-haul trucks, that happens naturally when you're driving down the road, driving down the highway. The engine is operating under sustained load. But terminal tractors, they rarely see that kind of operation. And so they're typically running at those low speeds with a lot of stop and go and idling. And because of that, passive regeneration doesn't happen very often. So the truck, right, then has to rely on active or parked regenerations, where the system intentionally heats up the filter. And those events can be disruptive to operations, as you can imagine.
Yeah.
They're parked. And if the soot can't be cleared out, right, effectively, it eventually builds up, right, to the point where the filter has to be cleaned manually. And that means taking the vehicle out of service.
Not good.
Which also isn't good. So across many fleets, the aftertreatment and regen-related issues are consistently one of the biggest contributors to unplanned downtime.
Interesting. Okay.
So the duty cycle of terminal tractors tends to make that problem even more pronounced than what you would see on, right, a long haul tractor.
Okay, so basically the diesel system is actively fighting against its own design parameters. Kind of every hour a terminal tractor is even operating in a yard. So what does an electric alternative actually look like in a real deployed fleet?
Yeah, so in real fleets, the interesting thing is how normal it all looks. And honestly, that's kind of the point. When you talk to operators who've deployed electric terminal tractors, you tend to hear the same few things. First, they do the work, which is
That's
great.
good.
Electric yard trucks, right? They're matching the diesel in terms of pulling power, their response time, and overall shift productivity when the duty cycle and charging are set up right, obviously. So drivers tend to like them too. That instant torque that they feel makes it easy to get trailers moving. And the control, right, is really smooth when you're maneuvering around in a tight yard. Yeah. So a lot of fleets say the drivers who were skeptical at first, right, they're actually requesting the electric units, like we've been saying, right? Like we've heard before. So when things really get interesting is the uptime and reliability. So when you remove that engine, the diesel engine, the transmission, that after treatment system I brought up, a lot of the biggest sources of that unplanned downtime just disappear. So you've got no DPF issues, no regen problems, no DEF systems to deal with. What's left is mainly, right, your tires, your brakes. It's a much simpler driveline.
Okay.
And, fleets that track this closely, they're seeing fewer road calls and more predictable maintenance.
Nice.
And then the economics start to show up, right, where energy costs per hour drop when you move from diesel to electricity, and then the maintenance costs come down because you're not dealing with, all of those systems.
Yep.
So when you combine that with the better air quality, the lower noise, easier permitting, honestly, for places like ports or distribution centers, the electric units stop being, right, small pilot projects, and they start becoming the default choice for a lot of fleets looking for new.
Yeah.
So the short version is this. In real deployments, right, electric terminal tractors, they look like a normal piece of fleet equipment, which is great. And they keep up with diesel on performance and quietly start to win on things like cost, uptime, and just the work environment in general.
All right. Well, then how do we go about selecting the right battery for that terminal tractor?
Yeah. So when you look at the battery selection for terminal tractors, it really comes down to two main things: the duty cycle of the truck and the packaging constraints on the vehicle. So the duty cycle varies quite a bit depending on where the truck operates. So port tractors, like in a container yard or row operations, they tend to deal with heavier loads, steeper ramps, harsher environments. And then you can compare that to a distribution center yard tractor where, the hulls are shorter, the ground's flatter, the loads are usually lighter.
Okay.
And so because of that, the battery size is going to land in different places.
Okay.
So for a single shift, distribution center operation, something like a 100 to 150 kilowatt hour range battery is often enough. In port environments, that can push past 200 kilowatt hours, especially if the trucks are running on multiple shifts.
Okay.
So once you understand the operation, your energy, right, math is actually pretty straightforward. You need to look at things like, trailer moves per shift, your average haul distance, grades, idle time, shift structure, and charging is a big factor to play in that as well. So for example, a 150 kilowatt fast charger during a 30-minute shift change really can recover about 75 kilowatt hours.
Oh, wow. Okay.
Which can really help bridge, right, the shift change without needing to oversize the battery.
Yeah.
So the other big factor I mentioned is packaging, and that's often, the real constraint. So most terminal tractors, they use diesel-based chassis. So the available space for the batteries is going to be limited.
Okay.
Right? So usually between the frame rails of the chassis itself. And so that's why, right, a modular battery pack is also very valuable. So if you can add capacity in steps, you can actually support, right, your multiple truck variants, whether it's in a port or distribution center, utilizing the same building block.
That's nice. All right, so we are going to move into our final application here for the day. I'll be upfront with you. I saved this one for last deliberately, and that's because I think it's actually one of the most surprising once people hear kind of the full picture. And that's fire and emergency response. So this segment might seem like it doesn't quite fit naturally alongside mining and port equipment, but the use case is incredibly demanding and reliability is a non-negotiable. So Bradley, the operational case in this space is, I think, sometimes overshadowed just by like the dramatic visual or what we see of an electric fire truck, which honestly, is quite striking. But there is a really serious occupational health problem at fire stations right now that most people outside of fire service don't fully understand. Can you maybe talk a little bit about that?
Yeah, for sure. And this is something I didn't fully appreciate until I started digging into fire trucks. And honestly, the numbers are pretty staggering. So today, cancer is the #1 cause of death for firefighters. And in 2023, it accounted for about 72% of line of duty deaths, which is more than fires, vehicle incidents, and heart attacks combined.
That's awful.
So one of the major contributors is the diesel exhaust exposure inside fire stations. So fire trucks, they spend a lot of time idling for readiness checks or for quick response times. Sometimes 40 to 60% of their engine on time is idling. So that means diesel particulate and other carcinogens, they're really being pumped directly into, the station where the firefighters spend a lot of their time, They're there on 24-hour shifts, eating, sleeping, living. And so departments are trying, they try to mitigate this with exhaust extraction systems in the fire station, but those are expensive to install and maintain, as you can imagine. And so electric trucks, they change the equation because they remove the source of the problem. So there's no tailpipe, no idling emissions, and no diesel particulate filling the station.
Yeah.
So instead of just reducing exposure, you're actually eliminating a large portion of that at the station right from the source. And so that gives departments a real path to lowering that occupational cancer risk.
Yeah, I have a lot of family members who are actually firefighters, and that station exposure piece was something that I really hadn't even thought about until I got into this application. Yeah. They're literally living in the stations, and the procurement framing you're describing is really important because you're not just buying a vehicle, you're potentially changing the occupational health profile of an entire fire station. But what about on-scene performance? For fire apparatus OEMs, reliability is really, really important. These are some of the most demanding applications. And honestly, as someone who hopes to never need a fire truck to come show up, I would very much so like it to perform when it does get there.
Of course. So would I. And really, departments that have already, deployed electric pumpers in service, they're seeing strong results, which is great. Response times, they match diesel. Pump performance meets the same flow and pressure specs. And operationally, the mission doesn't change, which is good. So many firefighters who were skeptical at first, they're actually ending up, coming around and preferring it, which is a pretty common theme we're seeing. That instant torque that you experience from electric motor helps on, things. Also, the quieter cab makes it much easier for crews to communicate, at the site. So reliability is also built in. So most electric pumpers, they include an integrated diesel engine that automatically kicks in if the battery gets low during a long incident. Right? So there's no scenario where a truck shows up to a working fire and they can't pump, which would be awful. So at the end of the day, the key specs stay the same. The flow, the pressure, and capability, they match diesel. Electric isn't trading, mission performance for sustainability, but rather it's leveraging the best aspects of both powertrains to deliver the best performance.
Yeah, that's pretty awesome. And some of the other applications, we talked about noise reduction. You mentioned it here as well. Maybe you can go into a little more detail specifically for fire truck applications.
Absolutely. Noise reduction is actually one of the biggest wins with electric fire trucks, as you can imagine. At the station, they've got near silent startups, They're going to cut down on the noise in the station, which means crews, on a 24-hour shift, they can get more sleep and they have, more hearing protection. So also on the scene, electric pumpers, they're whisper quiet compared with diesel. So the operators, they can hear incident command clearly, and the IC can hear crew radio traffic without having to shout.
That's really important.
And as we know, clear communication in high stress situations like a fire, they're going to reduce mistakes and can save lives.
Yeah. So water ingress, obviously important, sustained high discharge, thermal management, and seamless backup integration. Fire apparatuses really do require a purpose-engineered approach to battery integration. You can't simply adapt it from another platform. So if I were a fire and rescue OEM, how would I think about selecting a battery supplier or a battery pack for this specific application?
Yeah, so the most important thing I'd say is starting the conversation early. So battery integration in fire apparatus affects vehicle layout, the center of gravity, the pump system architecture, the electrical system design, and serviceability. And those decisions compound, So if the battery supplier is brought in after all those major architecture decisions are made, you're constrained in ways that are usually expensive to kind of unwind.
Probably just a pain.
Just a pain to deal with. So for a fire apparatus specifically, I'd look for a supplier with extensive experience in sustained high discharge applications. So not just peak power applications. There's a difference between a battery that can deliver high current for a short sprint and one that can sustain high power output for, 30 to 60 minutes of pumping operation without any thermal issues.
Yeah.
So finally, I would say serviceability in the field is a huge factor. Fire departments, they don't have, dedicated battery engineering teams. So the systems, they need to support, the diagnosis and maintenance by the people who actually service the fleets themselves.
I think that makes total sense. Early engagement, which is a key theme I think we've talked about as well, sustained discharge capability, regulatory familiarity, and then field serviceability. Those are all differentiators that matter especially when the platform is a piece of life safety equipment.
For sure.
So we have covered a lot of ground today, 5 applications, each with their own operating environments and their own compelling case for why battery electric drivetrains deliver advantages that go well beyond just the sustainability aspects. So what ties all 5 together is this. The operational advantages are clear of electrification, and most powerful precisely in applications where diesel systems are working hardest against their own design limits. So in closed environments where ventilation costs outpace vehicle costs, high idle duty cycles that destroy after treatment systems, precision operations where noise and vibration and operator fatigue directly affect performance and safety, across all 5, battery selection should not be an afterthought. It is a true core engineering decision that shapes performance, reliability, total cost of ownership, and serviceability across the working life of the entire platform. Getting that right, understanding the specific duty cycle, the operating environment, the charging architecture, and the service constraints, it all requires a supplier who is truly a partner that engages at the engineering level, not just at the procurement level. And at Proterra, we have spent years building battery systems designed to perform in exactly these kinds of heavy-duty, demanding conditions. We have more than 55 million service miles across deployed platforms, including systems in transit, school bus, off-highway, heavy trucking, all manufactured right here in South Carolina. And we work alongside OEMs from early design through production integration as an application engineering partner. So Bradley, any final thoughts before we begin opening it up for questions?
Yeah, I just want to add this, that the questions we get from OEM engineers have fundamentally shifted. So it used to be, can electric equipment keep up with diesel? Mm-hmm. And that question is largely answered. Now it's more of how do we optimize our battery architecture for a specific duty cycle, customer requirements, and service constraints. And honestly, that's a much more interesting engineering problem to solve. And it's exactly the kind of work that Proterra is set up to do with our partners.